So the first thing you want to know is that the develop branch is basically the master branch. Master branch is not the master branch. So if you're working from the code, this is the latest code. This is what I think is running on the mainnet right now, right there on the develop branch. This code base is very large. I think it's like 150, 200,000 lines of code in total if you add it all up. Some of it here, some is in the TSS library, which is a separate repo. This repo is in gitlab.com/THORChain/Thor node. And there's also some Ethereum smart contract routers we're using also in the same GitLab/THORChain. But the vast majority of the code for the core protocol, almost all of it, vast majority of it is here in this repo. There are a bunch of different files and directories, which we don't really need to get into all of that. But the two primary things you want to be looking at are Bifrost, which is over here. So if you don't know already, Bifrost is it's a separate binary that each Thor node runs. That is the bridge to Bitcoin, to Ethereum, to Binance, to Litecoin, to Bitcoin Cash. And over time, more chain clients will be added to Polkadot and Zilliqa, whatever, doesn't matter. Insert chain here. So effectively what happens is when a transaction happens in Bifrost, or rather on Bitcoin, there is a universal block scanner, just here, which is like the fundamental that implements this idea of like, okay, I'm going to wait. We're currently at block 1,000 of Bitcoin, and we're going to wait for 1,001, and then once we get 1,001, we're going to make a query to get a list of all the transactions of that particular block, and we're going to filter those transactions based upon looking for addresses that are owned and operated by the THORChain network itself, and then we're going to convert those transactions into a universal struct that all the chains can kind of utilize, and then we're going to ship it off to THORChain as an observation of money going into the system or money going out of the system in either direction. So this is used by all of the blockchains, all the chain implementations. In some cases, there's even which I just saw here, a scan mempool. In some cases, we scan mempools. In some cases, we don't. Depends on the chain. It depends on the situation. So, for example, I think we do scan the mempool for outbound transactions, so they don't reschedule things, but they're not really counted as things that actually took place until they're actually committed onto the chain, if I'm not mistaken. Same thing with this one. This one's scanning the blocks one by one. In some cases, this can be disabled via Mimir if need to, in the case of an attack of some kind, that kind of stuff. It also it can set the chain to unhealthy. And the chain is unhealthy, then it also stops signing transactions, which is the second part of what Bifrost does. So the second part is the signer, which I think most of the code's in here. And this is what it sounds like it does. It signs transactions outbound. This one does both one-of-one Udisoul wallets. It also does threshold signature signing as well. In this code base, I'm not sure if there's anything specific to go over here. You can look through this code as you need to. I mean, this whole thing, I could spend 12 hours talking about this code base, which obviously would be way too long. But you can.
Well, and also, like as you're running through this, anybody on the call, like, feel free to ask questions as you're running through. Like, yeah.
If something I said doesn't make any sense, or ask me, wanting me to dive a little bit deeper into it. If I'm going pretty quick here, and that's partially intention, partially because I'm an asshole. But if you have any like specific questions or like ask me to go dive deeper into a certain concept, please feel free to do so.
Yeah, one question on the block scanner. So is there a different implementation for each chain of the block scanner? Okay.
So you'll find I think actually, no, I think it was just in. Yeah, well, before I do that, let me do something first, which is relative to that. So the chain clients have this interface here that they all have to implement, right? And these are just it's an interface that how to sign a transaction, how to broadcast a transaction, how to get the current block height, how to get stuff. There's various little pieces of information, right? Every chain needs to implement their own versions of this. Although this one you could probably just delete because it's actually implemented automatically for you. But anywho, there's another one and here for example, fetch TXs. So here it just passes a block height and then responds with a type of TXN, which has, the count, the chain that it is, which could be, BNB or Bitcoin, whatever, the list of transaction items, which is defined here of here's block height, here's the transaction ID, here's the memo that's associated with it, the from, the coins that were there, the gas that was reserved, and then the vault that it was sent to or from, depending upon what direction the funds are going, to the network or from the network. So every chain just kind of breaks down every transaction as this standard format, which then you can pass it off to THORChain, and THORChain can be completely agnostic about the actual Thor node code, is almost 99% at least agnostic about what chain this is, what asset this is. None of all that's, pretty much treated the same as anything else. And then in here, I think there's one part here of like set, finalize, and unfinalize. I think this is around confirmation counts. Confirmation counts are like 0 for BNB because it's instant finality, but for Bitcoin, it's variable depending upon the value of the assets coming over to the network. Confirmation counts, I don't think happen on the outbounds. I can't remember because it's our own network sending it, but different on the inbound. Although I could be mistaken about that. Jumping back, so each chain client implements these functions, and then the universal kind of block scanner and the signers just kind of utilize those functions of the individual chain clients to get transactions and sign transactions. So you don't even have to write your own block scanner per se. You can just rely on the one that's already here, and you just kind of write these little functions that just gets data, which is relatively pretty simple to do in most cases, but not necessarily all cases. At a very high level, that is the block scanner at a very high level.
This is not something that's like invoked, right? This is something that's happening continuously. Blocks are just being scanned on every chain continuously.
Yeah. Effectively, each one gets their own. Each like chain client implements their own new block scanner here, like their own new struct or instance of a struct, more accurately, right? And then they have this, I think it's like a start function or something like that somewhere here. Yeah, start function. It actually starts it. And it has a global TX queue, which is where it's just all the different chains just dump into the same queue of things to be broadcast to THORChain. Observations, I have just observed that, Gavin sent me 1 Bitcoin to my address here, and I want to make the chain aware of that, the state chain aware of that, and to operate on that and do something with it, swap with it, add liquidity, withdraw liquidity, donate funds, who knows, like whatever the thing is. And so each one has their own scanner that it scans one by one. And so it usually looks for, where is that? Yeah, here. Here it's like looking for fetch transactions for whatever chain client, this might be BNB, it might be Bitcoin, whatever, for the current block. And if it gets an error where like the block is unavailable because the block hasn't been committed yet, right? We're still waiting 10 minutes for the next block to happen. It just kind of goes to sleep for a little bit and then retries in a few seconds later, and then comes back up and says, hey, is this next block available yet? Oh, it is available. Okay, cool. Get me all the transactions for that block. And then it processes all those things. And then when it processes all those things, it kind of just dumps them into this queue, this channel or global TX queue item, which is here, which I think is reused everywhere, if I'm not mistaken. And then when it broadcasts those things to THORChain, it kind of bundles a bunch of them together, like 100 transactions per transaction, like 100 observations per transaction to THORChain. So it's not necessarily that for every swap, and in each node, each independent node does this, right? So if you have 100 nodes on the network, you have 100 observations on the network, or 100 transactions on THORChain. But it's not necessarily like one swap to one observation ratio, because you can put 100 in one transaction or one transaction to THORChain to optimize in the block space. So it scales up pretty well, especially in high frequency situations where you have tons of transactions happening on the chain. It should be able to handle like much more than every Bitcoin transaction, every Ethereum transaction, every Bitcoin cash. You can probably almost add up the block space of all the blockchains together, and you would probably not be able to fill this up. But in terms of scalability of it, does that make sense to everybody so far? Any immediate questions? Or, and a lot of these things, another thing is like the other things are written to disk. So when it makes an when it pulls stuff from the chain from like Bitcoin, instead of just pumping it directly to someplace else, it actually puts it to disk first, and then it reads it from disk to make the observations, just in case the node gets like restarted somehow, or it gets killed or panics or something like this. We don't drop transactions or observations on the floor. They get temporarily put to disk. And then for the signer stuff, for the signer side of it, the things that it needs to sign, it encrypts that stuff using the passphrase of the wallet to encrypt it to disk first before doing it. Just so if somebody pwned the node, they could just insert more things to sign out and manipulate systems that way. They would have to have the passcode to do that. And if you have the passcode, then you can already just move the funds anyway. So you don't need to do this anymore.
You using level DB for writing it to disk, or is that just?
Yeah, I think it's level DB if I'm not mistaken.
Okay.
Yeah, level DB is getting
Okay.
storage. Simple KV store. Nothing too crazy about it.
That's good. Thank
Yeah.
you.
Are uncles handled downstream from this, or I just wasn't seeing much in the code in regard to uncles, or are these just kind of like pending transactions until like some delay per blockchain type thing?
Yeah, so if you're talking about uncles on the Ethereum side of the world, right? So how that is handled, if I'm not mistaken, and the Bifrost code is not my area of expertise, it's somebody else's, but I'll do the best I can. When we see a situation where we get a transaction, we have a number of conf counts, we will observe that transaction immediately, saying, hey, we've discovered this transaction exists, but we're not going to act upon it yet. We're not going to like actually do anything with that. We're just going to notify THORChain that like we see something happening that's about to happen, but we're not going to act on it yet. We're just going to like let you know that's there. And that's pretty much there because we want people to query Thor node immediately to get a status of like, hey, have you seen my transaction yet, right? And rather than waiting 20 minutes before THORChain even acknowledges the existence of your transaction. Once it gets to a certain conf count, and the conf count is relative to the value of the transaction coming in, or actually I think a sum of the value of the transactions coming in per block. So like Bitcoin right now is like 6.25 Bitcoins per block. That's the block reward. So if you are 6.25 block Bitcoins in a block or less, it'll get instant confirmation. One conf is all you need. You don't need to go 6, like is what a lot of people tend to do in the industry. But if you do over 6.25, it is a multiple of that as the farther you go. So if you get to 13, that would be 3 blocks. If you get to 15, it would be, so forth and so on, to the number of confirmations. The network also has something do something called what we call an Errata transaction, which we see this because of uncles on Ethereum more or less pretty commonly. And an Errata transaction is basically when the chain gets reorged and certain transactions are ripped out from a double spend attack, for example. The network will observe that, oh, this transaction that we processed previously is now been, reorged out of the system. And so we're going to do an Errata transaction to THORChain to like undo whatever the thing is that thing was designed or intended to do. And it will undo that to the best of its ability. If you did a swap and the funds are already gone, the funds are already gone. But confirmation counts should protect the network well enough from that situation, hopefully. Does that make sense? Did I answer that question?
Yeah, thanks.
Yeah. These are all pretty, each chain client is relatively complicated or simple depending on which one you're talking about. Like BNB is probably the easiest one because it's instant finality. Ethereum and Bitcoin are more complex, partially because they're, like UTXO management by itself is a kind of a complicated topic to how you handle that. Gas management is another really complicated topic of like how you do that. Like, we use child pays for parent pretty well in the Bitcoin side of the world, if you're familiar with that concept. But that doesn't exist in Ethereum, and Ethereum has its own kind of complexities around gas. It's that was a difficult thing in the beginning we first launched UTXOs and Ethereum, kind of getting the gas right, which is a kind of a tricky puzzle to some degree. But that's all pretty much ironed out, I think, for the most part, at least. Okay.
Chad, sorry, I just wanted
Yeah.
to ask, how do you establish connection to each blockchain?
Good question. So in a Thor node, you're running a lot of different binaries. I think there's like 7 or 8 in total, or 9 or something like this. But one of them is you're running a full Bitcoin, a full Ethereum, a full Binance, a full Bitcoin Cash, et cetera, et cetera. And so you're using your own full node to connect to that node to get the data about what's happening. And this is important because you don't want everybody connecting to the same, public node that exists. Like, Binance has public nodes, for example. Bitcoin doesn't, but Binance does. And you don't want everybody connecting to the same Binance node, because then you kind of ruin the decentralization or the centralization aspect to it. Like you become more, that one node could emit bad data, for example. So everybody runs their own individual nodes. And as well, that actually gives a little protection against like reorgs a little bit, because different nodes will, if the chain splits, if Bitcoin splits for some reason, and different nodes are now on different versions of the chain, in a division situation, you'll have that division in our nodes as well, and you won't get consensus to actually act upon any transaction if half the nodes think this is happening and half the nodes think that's happening. They won't get a consensus, 2/3 majority, and therefore they won't act upon whatever is happening on this until they all kind of get back together again, and the longest chain wins, and all this kind of gets settled in the UTXO world. But until that happens, the division actually helps the chain be protected against some aspects of attack.
So is the client connection constrained by the blockchain that you connect into with regards to the security controls that you can put in place?
Yeah, the connection you're making to your own full node is running within your Kubernetes environment. If you're running with a standard issue Thor node deployment, so you have full, complete, isolated control to your own node. It's actually happening internally to your own network. It's not even, you don't even need to make your Bitcoin node publicly available to the world. You can just keep it all, neat and tidy inside your own, VPC or whatever you're going to use. That all is controlled by you as an individual. Cool.
Chad.
Yep, hope it makes sense. Okay. We could spend time on each one of these chain clients, which might be too much for right now. One thing we could talk about is this kind of idea right here real quick about Yggdrasil. So the network has 2 different concepts of vaults. There's the Asgard vault, which is a threshold signature multi-party computation vault comprised of 40 nodes. If there could be an n number of Asgard vaults within the network, so it can scale up to as large as it needs to. And then there's these Yggdrasil vaults, which is basically a one-of-one wallet, a regular old standard issue wallet. The Asgard vaults tend to be the ingress. So if people are sending in funds, they send into Asgard. And then the network tells Yggdrasil to send out funds for swaps, for withdrawals, whatever that is. And so those can send out funds, really, really, really fast. As fast as you can sign transactions, which is measured in milliseconds. But threshold signatures get more and more slow quadratically, I believe. The more nodes more members of the party, members of the party that you have within an Asgard vault or TSS threshold signature. Right now, I think it's probably around like 15 seconds to sign transaction, about 15 seconds. The complexity now is with Bitcoin, with UTXO, because as you guys may know, you don't sign a transaction when you sign transaction of Bitcoin. You sign multiple UTXOs potentially, depending on how many UTXOs you're putting in your transaction. You're signing each individual one to create one outbound transactions. So that puts a lot of more pressure and weight on threshold signatures to sign that effectively. And so there's a whole like UTXO consolidation logic in the code to, as we get input of all these swaps coming into to Asgard, it's got to like re-sign things back to itself to condense the UTXOs to a smaller quantity. And so it kind of maintains its own UTX handling internally to itself, just signing transactions back to itself to consolidate those UTXOs into smaller and smaller, to larger UTXOs, smaller quantity of them. And so Asgard will send funds funds from TSS vaults to Yggdrasil, and Yggdrasil will sign out funds, and every once in a while, Asgard will just kind of do one transaction that's topped up their Bitcoin or topped up their Ethereum, and they'll just keep on churning out smaller transactions all the time in terms of to keep the performance up, so that the network can actually handle hundreds of swaps per second and still be able to pump them out just as fast as they're getting in. There's actually a hard limit right now on the number of swaps per block the network can take. I think it's like 100 swaps per block right now, which is an artificial limit. We can increase that as high as we wanted to. That's there for other reasons, which I'm not going to get to right now. But yeah, so there's Yggdrasil vaults and there's Asgard vaults, and Bifrost signs transactions from both of those things, and observes transactions for both those things. Any of those wallets get funds coming in or funds going out, they all get observed by Bifrost and beamed into THORChain, and then reach consensus and then acted upon in one form or another. Cool. Okay. I'm trying to think if there's anything else within the Bifrost world that is really important to go over from a high level. I don't think so. I mean, there are some implementation details within each thing of how UTXOs are done versus this versus sequence numbers and nonces and like all this stuff, but I don't.
There's a lot of surface area here, Chad. So like, what's the code that's touched also most often? And what's the stuff that hasn't been touched in a while? Like just in terms of the stuff that's, yeah.
Yeah, that's a good question. Like this, like I think the code gets touched most often right now is probably just the chain clients themselves. The actual like shared code within Bifrost hasn't changed all that much in the last 6 months, to my knowledge. Most of the code is about tweaking the UTXO management, tweaking gas, stuff, tweaking on smart contract, interactions and this kind of stuff to solve some recent exploits, that kind of stuff. And even Ethereum has like this whole thing about unstuck, because like if you don't have enough gas in a transaction, it just sits there forever and you can't send any other transactions, just gets stuck behind it. And so it has an ability to unstuck itself, to cancel a transaction if it's not, doesn't have enough gas somehow. If all of a sudden Ethereum got some sort of big, massive change in gas requirements, the network will observe that and cancel a transaction and then reschedule it again. Yeah, I think that's. Does that answer your question, Gavin? Did I do okay with that?
Yeah.
And this Thor client thing is just, it's like an API to THORChain itself, so the Thor node API, pulling down data and information and that kind of stuff. Oh, one thing is actually interesting here. So Bifrost pulls from Thor node a list of transactions to sign. Like it's basically a whitelist of transactions that are allowed your Yggdrasil or Asgard vault to sign out transactions. And in order to stop kind of a man-in-the-middle attack between Thor node API and Bifrost, you could set up a little shim thing in the middle of that to send a kind of false, data, false things to sign out. So what ends up happening is that the Thor node and the Bifrost both have access to the private key of this particular node, and it signs the data. So when Bifrost requests for like, hey, give me a list of transactions to sign outbound, it gives a list of transactions on outbound, but then also gives it a signature using the private key of that data. So in case there's some middleman kind of inserting something in the middle of it to manipulate that, the signature wouldn't be there and wouldn't trust it, and it wouldn't sign anything out as a security related reinforcement there. The only way we can do that is getting access to the private key itself. And if you access the private key, you don't really care about touching Thor node or Bifrost. You can just sign transactions yourself. So that's there for security purposes. Oh, and there's the TSS code right there, or at least part of it. This is the implementation of the TSS code. There's a separate repo, which I think it's Go TSS, I think this is it. I haven't pulled this in a while. This is the actual TSS code. Most of this code is written by a cryptographer on our team. He wrote a PhD in specifically threshold signatures, and so we hired him to the team to actually do our implementation, make sure we're not leaking any K values or anything like this, which is what happened at AnySwap the other day. They got hacked because of that, lost some funds. That code is also in the THORChain GitLab as well, if you want to look at that code as well. Okay, so that's Bifrost at a high level. Is there anything specifically in Bifrost that you want to know more about before I move on to the chain stuff?
Just with regards to the keys and with regards to TSS, any keys that are generated, how are they stored and secured?
Yeah, that's a good question. Let me think about that. I think the TSS shares are stored on disk in JSON in plain text, actually. And you might say that's a terrible idea. I actually probably agree with you. But a TSS share by itself is not a problem. You can't really do anything with it. It only becomes a problem if you get access to 2/3 majority of the network. Then it becomes a significant issue. I think it's stored in plaintext, if I'm not mistaken. But even the private key of the validator itself is also stored in plaintext, which is a design choice of Cosmos itself. So, I mean, that probably can be improved, which we'll probably work on that in the future at some point.
Yeah. What was the reason behind that design choice? Do you recall?
I mean, I don't think there's a specific reason for it. In order for you to like put it on disk and encrypt it, you have to have some sort of password. And if you're going to put a password on it, then where are you going to put that password? And right now, the suggested thing for Kubernetes is put it as an environment variable.
Yeah.
which is not great either. So you're really not adding more security by putting it as an environment variable, obviously. And so what really needs to happen in order to make this more secure is to have some sort of vault system of some kind of form. And then there is a vault, there's something called Vault, if I'm not mistaken, to do that. And that's something that's on the kind of the backlog to improve on the infrastructure security side of things.
Would the key be specific to the Tor node operator, or would it be the same across all nodes?
What, the TSS share?
Yeah.
No, that's unique per node. I could be wrong though. I could actually, maybe we did actually do the work to encrypt it with the same password that's used to encrypt the key store for Thor node itself. I could just not. We could have done the work a while ago, and I just missed it. That's also possible.
Possibly, yeah.
Yeah.
Yeah, I guess if it was unique to each Tor node operator, they could secure the key through their own mechanism. They could set a password rather than it being, and that'd be an improvement over plaintext. But I'm sure there are other options out there.
Yeah, and we do have so each Thor node has its own password that it uses to encrypt the key store for Thor node itself, and maybe that can just be reused for this particular thing as well. And it probably should be, if it's not already. It may already be done, and I just forgot that we did it. We have another person on the team that works on the infrastructure side of things, and so I don't manage that on a day-to-day basis per se.
Sure.
So I could just be forgetting, which is very well possible. Somebody can check that for me.
Yeah, no worries.
Yep. And we've had a pen test on the Thor nodes themselves to have somebody try to break into them, and it did pass. Which is a good thing, which obviously doesn't mean it's secure necessarily, but we've done at least some auditing of that part of the stuff.
That's
and
good.
We actually have more auditors. Trailblitz is on the call here, and also Halborn's on the call, and that's one of the things that we're going to get asked to do is to further push on this road in a sense.
Okay, great.
Okay.
Quick question. Could you tell me a bit about the murmur feature? I saw in the documentation. And the documentation says feature allows admins to change constants. How does that work?
Yeah, good question. So Mimir, as I call it, I don't know if that's the correct way to pronounce it, but that's the way that I pronounce it. I'm not Norse myself, so. But so Mimir is administrative keys. There are 2 keys in existence controlled by the team. And that gives the team ability to make on-the-fly changes, configuration changes to the network, based upon the requirements of the network, right? This is something that's intended to be used for during chaosnet, while the network is kind of getting its training wheels, and while it's kind of weaker moment of trying to find its footing and get that security. Generally speaking, in most cases, it's an ability to change these constants, which are really more configurations than constants. We call them constants because it has to be constant throughout the network. You can't have one node have one value and another had another value, that would cause a consensus failure. But these values can, at least some of them at least, can be configured and changed by the Mimir setting, which was used sometimes in very dire situations where we needed to halt churning, for example, because there was a gas bug and we didn't want to abandon funds on the previous vault whenever the network churns. And so that's used sometimes to kind of help out when there's some significant issue or problem by the team. Eventually, Mimir will be passed over to the node operators for them to decide these kind of factors. Once we go mainnet, that'll be just passed off, and the team will kind of just back away and burn the keys and all that. Not to burn the keys, but just remove them from the system. In fact, there's actually a command in Mimir called release the Kraken that destroys Mimir. Because the story of Mimir in Norse mythology is that it's a guy who gets his head chopped off at the end of the story. And that's why we chose Mimir as the name, because it was intended to be something that exists just temporarily, just to help the network. It makes really sudden changes if there's some sort of security related issue, just to put it while I get those training wheels on. And then once we feel confident in the network and it's been reliable, secure for an extended period of time, then we just release the Kraken, and then just the whole thing just basically destroys itself.
So Chad, really quick, for this right now, currently, it can be updated, the constants, by like admins, and then it's going to be consensus by the validators to decide what the new constants will be, and then later on it'll be like a revoke ownership to from everybody.
Yeah, so in the future, these values can be set by Mimir via the node operators themselves, and that reaches consensus. I think that's the intention, at least for some of these. And to be clear, like, Mimir doesn't give anybody the ability to like extract funds. Like, nobody can take funds this way, anything like this. It's just to change the behavior of the network a little bit to protect it in dangerous scenarios predominantly.
Mm-hmm.
But if the community wanted to change, say the observations right here, observation flexibility delay, for example. And so what this particular one does is, if somebody makes an observation of a transaction, you basically have 10 blocks to also make that transaction to reach the consensus. If you do it after that point, after the change reach consensus on this, then you're slashed effectively for doing that. You won't get your slash points back. So because you don't want people to flood the network with old observations from like 10 years ago on Bitcoin or something like this, like that wouldn't be beneficial for the network, and that should have a cost to it. So, but if the community thought, okay, 10 is too little, let's change it to 20 or whatever, then a code change can be made. It can go out, and the community can adopt that code change or don't adopt that code change. The community decide. Or that can be maybe set via Mimir setting, which would be not so much a code change, but just each individual node just kind of like clicking into the system and just saying, I vote to change this to 20.
I'm just wondering about the consensus, because I'm thinking about like an attack, for instance, like the churn interval, how many blocks to rotate validators. If like maybe you time it where you right now are in like the validator set to do it, and then you propose churn interval to be like infinity, so now it'll never rotate anymore and kind of like just stay with you.
Well, so in order for that to happen, you would need to convince the community to adopt it, 2/3 majority, before it actually would become
that's what I was wondering.
Real. Okay. Yeah. And in that case, you would never do that, because you would never get your bond back, because you can't make a profit. In order to make a profit as a node, you have to leave. So you bond in, you get churned in, you make some money, validating blocks and whatnot, and then you leave the network. Then you have access to your bond again, including the profits that you made by validating blocks. So you want to leave the network at some point in order to take profits, in order to realize your income.
Yeah, it was just like an off the cuff like idea of just changing logic that could be advantageous to an attacker, or a malicious validator or something.
For right now, the team has the ability to change these in effectively in a unilateral way, in a centralized way, which is by design and on purpose in the interim. But nobody wants, including myself or anybody else, wants to maintain that in the long term. It's just to help. You don't want to, when you bring a project, every project starts centralized and then moves to decentralization, including Bitcoin. And you don't want to go from centralized to decentralized like overnight. That would be completely irrational and
awesome. Yeah, no, it makes sense. Like the training wheels, like you say, and I get it. I support that. for like findings when Halborn and the guys from Trail of Bits are doing this assessment, high level, should we anticipate findings that, hey, this is like a training wheels finding, but on the mature network, this won't be an issue because we're changing it. So like how should we report those two types of, I guess, architectures?
Yeah, I mean, that's a good point. However you see fit, if you see something as a threat or an issue, voice it, and we'll listen to it,
Cool. Great, thanks.
That's good. Thank you.
Oh, by the way, I mentioned this earlier about maximum swaps per block is currently set to 100. Like, this is just a configuration thing, so we can go ahead and set it to 200, whatever. It's pretty arbitrary. Set to 100 for now, but they can increase it to as much as they want to for the most part. Okay, I can go through all these constants. They all mean a lot of things. They're all commented here, so hopefully this is self-explanatory.
Yeah.
But I could spend a half hour just explaining each one of these things. It's a lot.
The comments are fine.
Yeah. Thank you.
Comments should be good enough. Okay. All right. So most of the Thor node code is in the X THORChain directory. This is the standard within the Cosmos realm. Everything's in X / module name / whatever. This is the vast majority of all the code. Instantly, you'll see there's a lot of files in here. I think it's like almost 200, which is a good amount, I'd say. And you might also notice that there are, version 59, version 45, version 1, and you'll see this throughout the code in many places. Why is that like that? This is actually kind of an interesting thing. So what's unique about THORChain versus other Cosmos applications and blockchains in general is that it has an ability to do an asynchronous upgrade. Typically in like Cosmos, for example, like Gaia, in order to upgrade the chain, you have to do a synchronous upgrade. You have to plan block height of like, at block height 1 million, we're going to upgrade from version 1 to version 2. And then everybody in the network, collectively says, okay, we're all going to wake up at this time. We're going to shut down the nodes. We're going to export the KV store. We're going to make some changes to that export that is typically in a JSON file, and change some values, whatever the hell that's going to be. And then we're going to start a brand new chain, destroying the old one, and then have a new genesis with a new block height and a new all these things continuing on. That's interesting, but it's very difficult and complicated to do. And for that reason, Gaia only does updates like every 6 months or so, which is pretty slow from a dev cycle perspective, especially in the early days of a dev cycle, like the life cycle of a project. So what's different about THORChain is that it actually maintains compatibility with all versions of Thor nodes' previous history. So every code change that happens, you never destroy the previous behavior, you just create a new behavior. And so the old behavior gets executed at blocks, up to block 1 million or whatever. And then at 1,000,001, all the nodes had upgraded their nodes from version 1 to version 2 at whatever block height that happened to be at. And then all the nodes synchronously change from version 1 to version 2 and then carry on. So for the most part, you can probably just disregard the version 1, version 47, version 50, blah, 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 and just look at the highest number. This number is always representative of the version that this was changed at. So even though we're running version 62.1 now, I think it is, version 58 being the highest number is one that's actually the code that's actually being used in version 68. This version this signifies the version which the change actually took place, and everything after that is let's see, it looks like this. There's a lot of, you see this logic around everywhere in the code more or less to manage this versioning. Where if it's above 58, it's run this thing. So if it's 59, 60, 61, 700, it doesn't matter. And so it just kind of routes code executions on a block by block basis. Okay, so we have handlers and we have managers in this directory, and a few little bits and bobs as well. Handlers are pretty standard issue in the Cosmos realm. It's what's processes some sort of request or transaction. There are a lot of these things that do a lot of different things. I'm not sure if I spent time going through all of them, but I should go through a few of them that are important. Normally in a Cosmos blockchain, you have different handlers, and then you have different endpoints to trigger those handlers, and you post some JSON to an endpoint, and you say, okay, here's my from address, here's my to address, here's my my name and my last name, and to set my name inside this blockchain to be Chad Barrow or whatever, this hypothetical chain, and you just broadcast that data to the chain directly. But THORChain is very different because you have to be able to broadcast transactions from Bitcoin, from Ethereum, from Binance, and other chains, which is not talking to Thor node directly, nor does it have Rune as a gas, right? So you can't even do that. And so instead, it uses the memo in the transaction. For Bitcoin, it's called an off return, and for BNB, it's called memo, where you have an encoded transaction state. And I'll show you what that looks like here. There's a directory called memo. I'll do like something like bond, for example, is a simpler example. And so we're passing in a string, which is delimited by semicolons. So that's would look like bond or one some address, whatever that might be. And so it's going to parse that and say, okay, here's the address being parsed, blah, 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 and then here's the new memo here, which is in the memo struct. It has the node address that's being processed by that string that I just passed, which is an example of what the bond string, the bond memo looks like. And so it gets parsed, and I think it's in handler.go. The cat lock on? Weird. Took forever. So it takes in a string here, parses it into a struct, and then calculates from that what the intent is, and then creates a new message, a Cosmos message, which you can see. Oops. There you go, right there. Cosmos message, which is now we're in the Cosmos code, by the way, as the interface. So it converts the memo into a Cosmos message and then responds with that Cosmos message. And then it gets routed through a handler router, which is defined basically here in handler.go. There are actually two of these. There's external handler, and there's an internal handler. External is for the node operators to observe transactions that are outside the network, I believe. And internal handler are transactions that are done directly onto Thor node, like through a broadcaster transaction to Thor node itself. Each one of these things gets processed. So it creates this little router. So the example would be an handler to observe inbound transaction, for example, like that. Show you what that is. Just a second to find it. Yeah, so here we have the handler here. It's creating a handler, which is like a router. Now that's it observed the transaction from externally first, and it got consensus on it, and now it's going to run the internal handler part of it to broadcast, to do the action intent, which would be 963. This is where it processes the memo into a message, a Cosmos message, which is this little M value right here. Let's check to see if it needs to halt trading or not for swaps and add liquidity. And if not, it then just runs the handler here, which then executes add liquidity, swap, withdrawals, donate, bond, unbond, whatever those things are, and then returns with it. So these things, some of these handlers, like handler.deposit and handler observe transaction in, handler observe transaction out, those things don't really do anything unto themselves. They just reach a consensus of one form or another, and they pass the message into the router to be sent through another handler, second handler, to execute some sort of logic or code of some kind. And we needed to have that on top of THORChain, which is very unique to THORChain, because we're interfacing with other blockchains, which we needed a protocol. Other blockchains could like send a message to THORChain without needing to like actually talk to THORChain directly. to like HB, handlers and that kind of stuff. That was an interesting thing to work on. Okay, all those handlers that you can see in any one of these handlers you go to, they're all versioned as well. Oops. As you can see here, here's like a validate function that's validate version 1 and validate version 55. There was some code change that was made. All of these things are versioned as we need to. So every time there's a code change, a new version is deployed to maintain backwards compatibility, so we don't get inconsistent failures when validating every block throughout history. Yes. Okay. I'm going to go through the handlers a little bit so you can know which ones are which. Oops. A brief explanation of each one of these is adding liquidity is what it sounds like. You're sending Bitcoin and Room, for example, into the Bitcoin pool. Ban is the ability for the nodes to be able to ban other nodes through a 2/3 majority. It costs money, actually a good deal of money, to do this, to execute this command for Thor nodes. But if they find that a node is being malicious in some way, shape, or form, this is their kind of exit strategy. And that node would get banned instantly. It wouldn't require a churn. They just get kicked out of the consensus immediately.
How do they initiate that, Chad?
Yeah, there's a, if you go to, there's like CLI. The CLI has a few different commands to it, like set node key, set version, set IP address, bans in there, as a Mimir command in there as well, as a deposit there. Nodes don't use deposit or send. That's just there for anybody else who wants to have a bash way of sending transactions, But you can do that by the CLI so you would just like SSH into your node and and you effectively do or node TX THORChain blah blah whatever.
Gotcha.
So they can go ahead and ban other nodes if they choose to. That's actually never happened quite yet. Maybe once it happened because there was one node like screwed up his node and one validator's like deleted his node basically or something like this and was causing a problem with churning or whatever in the early days of the network. Bonding is how you bond more room to your node. Common output this is reused by several different handlers. It's just kind of like it's some of the handlers like Ragnarok and out and blah 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 use the same. That's the same logic. So it's just a way of not rerunning the same code, keeping it dry. Consolidate is used by the network itself, not by the community or the users to consolidate UTXOs. Deposit is the rune-based router. As I told you before, it's a handler that calls other handlers, handler that routes to other handlers. Deposit, you just deposit some rune with a memo, and then that gets processed to execute one of these other handlers we're seeing in front of us. Donate is how you can donate to a pool if you want to. We would put this in there mostly for the team, so that if we wanted to donate money to a pool because for whatever reason we saw fit from the treasury, we could do that. In Errata transactions, what I was talking about before, to undo a transaction that was observed. This happens sometimes, especially with Ethereum and uncles and all that kind of stuff. IP addresses for nodes to set their IP address if it changes, which it almost never changes, but you need to set it the first time to make your IP address publicly known to the network. This is for nodes to leave the network. This is for Thor names, which hasn't been released yet. The code is fully functional, but hasn't been enabled. It's feature flagged off. Migrate is how the network migrates funds. So one thing I didn't talk about was that every time the network adds and removes nodes from its validator set, it creates a new series of wallets on Bitcoin, Ethereum, everything else. And then it has to migrate all the funds from the old validator set to the new validator set, which is typically almost the same, just plus or minus 2 people. And so every time that happens, it's got to migrate all the funds over, and this migrate function is used to handle that too. And it's always really done with that. I think it's just to reduce the amount of funds on the vault on vault A to vault B to increase them on that side, so that the network knows how much funds are on each wallet address. Mimir is what you think it is, setting up Mimir commands, network fees about nodes Bifrost telling the network how much gas costs for Ethereum or for Bitcoin, and then so it has a dynamic, continuous understanding of how much gas costs on those individual networks. No-op is similar to Donate, but it doesn't change the pool depths or doesn't change the vault quantity. So in a situation like we are now, actually, where the network is insolvent, it's lacking Ethereum, for example, the team would use the no-op handler here to send in funds, where it would take in the Ethereum but not increment its understanding of how much Ethereum is in a particular vault or how much Ethereum is in the pools. It gives that's just there for the team to be able to rectify accounting issues in production if they ever should arrive.
Chad, can I come back to the leave handler? Is that initiated by the Tor node operator?
Yes. Yep. That's something.
What does that effectively initiate? Does that any funds or liquidity that's held by that Tor node? What's happened? What's the process for them?
Good question. Yeah. So what happens is if you're a validator and you say, hey, I want out, like I don't want to be doing this anymore for whatever reason that you might see fit, you can request the network to leave, and that marks your node to say this person has requested to leave, which gives you first priority on the next churn to be pushed out of the network.
Yeah.
This happens sometimes. We've had people literally destroy their nodes by accident, or even purposely in one case, I think. There's a guy recently who just did make uninstall for some reason and just destroyed his entire system, even though it had millions of dollars on it. Blew my mind. But he would use the leave command, and when you do use the leave command, you're gone for good. You have to destroy your infrastructure and build brand new infrastructure. We don't want people just leaving and coming and going and abusing the logic of how the network churns and nodes in and out. We want the network to choose who gets churned in, who gets churned out. That best suits the network's needs, not individuals to choose that. And so we kind of harm the node operators when they leave, and by forcing them to destroy their infrastructure and build up new infrastructure, which takes days to do. So people won't use this command willy-nilly and muck about with it. That's only there if you're ready to leave and you're gone. And you're willing to spend days to rebuild your infrastructure if you ever come back. That make sense?
It does. I was just curious, the funds that maybe are held within the vault for each chain is how is that churned out if somebody wants to leave?
Yeah. So if you leave the network, as soon as you get churned out, you're no longer an active validator set. You're on the standby, so to speak. The network will then request to your Yggdrasil, say, hey, you've got this much Bitcoin, you've got this much Ethereum, you've got this much USDT, whatever, send it back on the network. And then the node basically has about, I think it's a half hour to comply. If you don't comply, then the network just assumes that you're not going to send back your funds. Maybe because your node is broken. Maybe because you destroyed your node by accident and you didn't keep your backup of your passphrase to recreate things, and you just fucked it all, right? And so the network say, hey, you didn't send back your funds within 30 minutes. So we're going to go ahead and assume that you've stolen it all. So we're going to slash your bond 1.5x the value of what you've stolen, and you can just go ahead and keep the Bitcoin, Ethereum, and all those things. And we'll take the bond we took from you, we'll dump it back into the pools which you basically stole from. And by putting that rune into those pools, the Bitcoin, the Ethereum will be just arbed back into the system just by natural markets.
Where's their bond stored then?
The bond stored on the chain itself. It's not stored in a special signature. It's not stored anywhere else. So in order to change the bond, or do anything with the bond, you need a 2/3 majority of the complete validator set to do so. In the earlier version on single chain chaosnet, it used to be a BEP2. Room was a BEP2 asset, not a native asset, and therefore it was stored in the threshold signature wallet, which at the time was fine because it required 2/3 majority anyway, because all the nodes could fit in a single TSS vault. But we wanted to go beyond a limit of 30 or 40 nodes. We wanted to have 100 nodes. We want to have 200 nodes. We want to have 300 nodes. And so we designed so that each Asgard can have multiple Asgard. We don't want to have the rune in there either, the bond in there. That would expose too much economic risk. So you need a 2/3 majority of the complete validator set to get your bond back. And your bond back is not coming back until you send us back that Bitcoin, that Ethereum, those other funds. And if you don't, that's fine too. You actually did everybody a favor. You lost a lot of money by doing so, and you made the pools actually deeper by doing so. So everybody will thank you for that. But that sucks for you.
Yeah, no, perfect. Yeah, thank you.
Yep. Observe TX in, observe TX out. This is what gets executed by the observers, the Bifrost, the Thor nodes. Do observe transactions in, observe transaction out. These kind of tally all the observations that each individual Bifrost node has recorded or pronounced for the community, to the blockchain itself. And then once it gets a 2/3 majority of like, all right, we all saw the same thing. This amount was sent from this address to that address with this memo, with this, gas amount, whatever it might be, it's complete agreement. Then it becomes routed into one of these other handlers we see on my screen here. Outbound TX is one of the things that when we send outbound checks, this one gets executed. So, if you just want to swap, the outbound TX is observed. This handler gets executed to update the vault, maybe, I think, or other things, or to ensure that it doesn't get stolen. That every transaction that comes out from the network has to be in the whitelist of valid transactions. If it's not whitelisted, it's considered to be theft, and that vault would get slashed, either Asgard or it would get slashed 1.5x, whatever just was taken out of the network. Ragnarok. Ragnarok is an interesting concept. It's something that's never happened in the network thus far. It will happen eventually on single chain chaos.net very soon because the network's being destroyed. Ragnarok, if you're not familiar, is just the story of like the destruction of Asgard in Norse mythology. And so basically this is designed that it gets executed if the network loses BFT. Because say the governments start to attack THORChain and make it illegal to run a node, whatever, and all the validators decide to mass exit, which has to happen in an orderly fashion somewhat. But if it gets to a place where it's going to lose Byzantine fault tolerance, it triggers a Ragnarok, which basically means it explodes out all of its funds to everybody. So everybody who's LP'd into it, everybody who's bonded into it, everybody who's participated economically in the system, all the funds just get exploded out and just dumped to everybody. And it's like a final result of like, this thing is going to be destroyed. So let's just, push everything out. Single chain chaos.net currently has like $5 million in the LP side of it sitting there. So that's going to be Ragnarok probably in a week or 2 or 3, whatever it's going to be.
So it's like a self-destruct transfer to all equal to all the validators.
Pretty much, it's pretty much what it's designed to be. Is a self-destruct functionality, and yeah, it's kind of.
And the Byzantine fault failure that triggers this, is it an instant based on some like value or variable, or is it like a time-based average that would trigger it?
No, as soon as you have a validator set that is no longer Byzantine fault tolerant, gets triggered.
Okay.
Instantaneously, and then because the validator set's very small, I can sign transactions relatively fast, even for official signatures, because there's only like 3 validators left in the network for some weird reason or cause or situation, and all the funds would just be signing transactions left and right, just dumping things out as fast as possible. Okay, so refund handler is executed when there's a refund. So if you try to do a swap and the swap is invalid or doesn't meet the trade requirements, or you send in a bad memo that doesn't make any sense, it triggers a refund to send you back your ETH or back your Bitcoin or back your Rune or whatever it might be. This handler gets executed when it observes the outbound of that refund. Reserve Contrib. This is a way of like donating funds into the reserve. This was used in the old network, not so much used in the new network, I don't think. No, I think it's still used actually. I think it's still used. So if you want to donate Rune into the reserve, here you go. You give money to everybody. The rest of the community can do that. That's probably there for the team. We have a large treasury, and we're dumping I think around 200 million Rune into the reserve. I don't know how much is in there now, but in the end, once we get to mainnet, it should be about 200 million Rune, which is worth, I don't know, close to $1 billion, over $1 billion, something like this. Send is just like sending native assets, like sending a Rune from one address to the other. This is for node operators to broadcast what their pub keys are. So in order to know whether you just sold, Bitcoin addresses, Ethereum addresses, what the Binance addresses, you broadcast what your pub key is. And from your pub key, you can derive your Bitcoin address or Ethereum address. And so you broadcast in the very beginning what your addresses are. This is for swapping, obviously. Switching is for upgrading from BEP2 rune or ETH.rune to native rune. TSS is when we do a TSS keygen, which is generating a new series of wallet addresses. When we do like a churn, for example, we trigger TSS. That's going to be updated soon to handle both ECDSA, EDDSA, whatever it is. Same thing for instead of keygen, we're doing key sign, which is sign transaction out, and observing we sign something. And then we do broadcast like timing to like how long it took to sign something. Unbonding is for nodes to unbond and get some of their bond back. Obviously, there are requirements that you don't have funds still in your USIL when that happens. And then version is when you tell a node tells the network that I've upgraded to version 2. You don't actually input your version; it just pulls it from itself. So you can't just say artificially say, "I'm in version 10,002." I mean, you could if you compiled your own binary and then broadcast that, I suppose, but that would be kind of pointless. And then withdraws, what it sounds like, withdrawing funds from the network from LP is the opposite of adding liquidity. It's withdrawing liquidity. And then USIL is the observation of sending funds to and from USIL, either USIL funding or USIL return in either direction. All right, that's the handlers in a nutshell. I didn't go into each individual one because that would take way too fucking long. But the next part is the managers, as you can see here. So what is a manager? It basically is a, I don't know how to describe it really. Some sort of protocol or a system, maybe is the right word to use, of managing some aspect to the network. This is for events, for example, emitting events. If you don't familiar with Cosmos, you can emit events on Cosmos, which can be ingested by third parties. We use that to emit events to Midgard, which is a separate service, separate binary that does all sorts of like, it gets every swap, every add liquidity, every withdrawal liquidity, every like pretty much everything that happens on the network. There's an event around it, and it kind of keeps track of how deep the pools are, how much liquidity person A built versus person B, and then it kind of rolls all that data up into a time series database, and so you can do all sorts of like analytical analysis of X, Y, and Z. Gas is tracking gas of external networks, like how much gas is it for Bitcoin or for Ethereum. Network is kind of a catch-all. We use it for a few purposes. We've actually used it less now than we did in the first version of it, but this is for tracking like how much rune is in the for tracking how much rune is in the for the bonders, like how much the money they're making, I believe. Other things, or might be missing something else. Oh, I think this is handling. Oh, so this is actually sorry. It's much more than I thought it was. I remember. This is doing churning. It's actually triggering churns. Figuring out how much to churn, how much does it need to churn. And when it churns, it doesn't move all the assets in one go. It moves assets, I think, over 6 iterations. So if you have like 1,000 Bitcoin, it moves it into 6 parts over time rather than just 1,000 Bitcoins in a single transaction. The reason why that is we want to make sure that assets are available at all times. And you don't have anything that's kind of like pending or in flux or in flight or any of these things. That would just create complexity and scenarios where the network wouldn't do so well to where it needs to top up a USIL. So every like 30 minutes, it just takes a segment like 1/6 of the funds and moves it over, then another 6 and move it over, another 6 and move it over. That's this code here. What else is in here? Trigger keygen. This tells the network to generate new addresses and broadcast that to the Bifrost nodes to generate new addresses. Anything else that's in here? Rotate vault, which just sounds like what it is. Rotating vaults. This is getting to conflicts and managing chains. This is something we need to work on in the future of like adding and removing live chains, which is kind of, the code's done, but not properly tested yet, which is why we haven't added any new chains network since we launched. I'm not gonna go over that. Okay, this is the update network, this is how like block rewards are basically handled. And like incentive pendulum and these things at the end of every block, we, emit some room from the reserve into the pools or into the nodes. We check out how much of the system income was made by swaps, and we kind of rebalance the system based on the incentive pendulum to figure out how much room should go to the pools, how much room should go into nodes, and then every block that's kind of handled in this code here. The manager observer, I think that's used for noticing when nodes aren't observing transactions. If a node goes offline, they're not observing Bitcoin transactions or Ethereum transactions, this code is executed, which eventually triggers this code, which is the slasher. The slasher is what it sounds like. It slashes nodes. It looks for like double signing, for example. If nodes start double signing blocks, that's a really bad thing. If nodes are observing, the slashing for that. If nodes are not signing transactions, they should be signing transactions, they get slashed for that. All that's handled there in the slasher. The store manager store is just kind of, I think, that's how the KV store is managed from block to block, or rather from version to version. We can do irregular state changes with this. Because we notice some bug, we have to undo some transactions, we have to change the depth of a pool because of some bug or a hack on the network. We do irregular state changes here to do some manual configuration changes or manual changes to state through this code here. The swap queue is what it sounds like. This gets executed at the end of every block. It does analysis of figuring out which swaps to do based upon what the highest swaps at the highest value. This is how the network actually defends itself against MEV attacks. It's not really practical to do MEV attacks on THORChain, which is pretty cool. All because of the queue. It's not first in, first out like it is on most chains, most DEXs. It's the swaps are actually organized by the ones that have the most value to the network. So bigger swaps get done first over smaller swaps. The TX out manager is what schedules outbound transactions. So you do a swap, the final result is it calls this manager to say, hey, send Steven this Bitcoin or whatever, and it's the one that does all the analysis for that. That little bit of code gets changed quite often. You can actually see by how many versions there are, like how often that code gets touched, versus something like the gas has never been touched since we launched MCCN. It's pretty stable code. But TX out gets changed a lot probably because it's really complicated code to some degree. What are we on here? 59, 58. There's a lot of really complicated logic in here. I'm not going to go through all of it. The main function that's called is this function here, try add TX out item, where it makes an attempt to send out outbound transactions, where most of that code is done through this prepare TX out item, where it does all sorts of checks and validations. This was an interesting thing. We got attacked by Bitcoin Cash blockchain once. It was where we were scheduling transactions on Bitcoin Cash, but they changed the address we were sending to within the blockchain itself. So we were like, hey, send to this address, and it would arrive on the blockchain, but the blockchain would say it went to this other address, which caused a leakage of funds in the network. Wasn't a lot of money, but it was just really annoying. So we had to do some conversion stuff. This is one of the examples of like where the chain is not 100% chain agnostic. It is 98% or 99% chain agnostic. It's really annoying. That's one of the struggles of this product is every chain is different. Even within UTXOs, it's still different. Even though they're all forks of Bitcoin, it's still different. So here is trying to define where to send funds to. There's all this clever logic around like, okay, we're going to find USILs that have enough funds to send it, and we're going to find the ones that are the most secure, meaning the bond, how much bond it has versus the how much value it has in the system. So if the bond somehow, some crazy way, happens, and the USILs have more funds than the bond would allow, the network would observe that and try to drain these funds as relatively fast as possible to get ahead of it. That never actually happened so far. I don't know why it would, but we put the logic in there just to protect the network just in case some weird edge case happens. but it can even find multiple utils. So if the trade is massive, it'll actually spread it out over multiple, cut it up into smaller pieces instead of multiple utils. And before it goes to Asgard's, and it falls back to Asgard's, so they can't do it for 3 utils. And then here it's just trying to like recalculate how much to send out because it has to keep account of like gas. So it takes a bunch of the funds out. So you're sending out 1 Bitcoin, but you're actually going to get 0.9 something because of the gas required to send it out, and also a fee to the network as well. That's that in a nutshell. Let's see here. Manage validator. That sounds, is this managing the validators? I haven't looked at this code in a long time, so I actually don't even remember what's in here. Yeah, this is where it's trying to define whether or not it should churn and then who it should churn out. So like, for example, there's a thing here that says mark old validator. And so this is how it decides who to get churned out. So it decides nodes based upon, currently it's actually 4 attributes now, which is kind of funny to me, but it's the oldest node. So that's somebody who's been running an active node for the longest period of time. It is the baddest node, which is the mark bad actor right there. There's also a low bond one here, which is the node with the lowest bond. And then there's a low version. So if the network decides to go from version 1 to version 2, and a 2/3 majority say, hey, we're now on version 2, the community has decided we're going to version 2. So it starts churning out the version 1 guys who have been holding out, not upgrading to version 1. So they eventually just get kicked out of the system after a few days. Although it's actually removing 1 node per churn. So if it's 10 nodes, it'll take 10 churns to kick out that last 1/3. But that hasn't happened really yet. Everybody's pretty on board with the changes being made. But that won't always be true.
How does the network decide what version it's on?
Yeah, so it goes through all the versions, also all the active nodes, and it says, okay, there's 100 active nodes, and 99 of them are on version 2, and 1 node's on version 1. Therefore, we're running version 1. And so version 2 guys have the logic to run version 1 and the logic to run version 2. So they can continue running the old code execution for as long as they need to, until that last 1 guy flips to version 2. And then in that very instant that he or she does that, in that block, all the code now runs on version 2. Or that person gets kicked out, whatever happens. But it requires 100% of the current active validator set to be running version 2 for the network to start actually executing the version 2 changes of version 2 logic. 100%. You need everybody. But once you get to 2/3 consensus that the network wants to move to it, the rest will eventually come over. It's a requirement because you won't be able to churn into the network unless you're version 2 as well. So your version 1s will be kicked out. Only version 2s will be churned in. So you're not going to get churned in unless you're on board with version 2 anyways. Yep.
What would happen if you had the same node meeting a few of the criteria that you just mentioned, where 1 node was the oldest and had the lowest bond and was on the oldest version? Like, would you only just churn out 1 node in that instance, or?
That's a good question. Typically the network tries to churn out 2 nodes in a common situation, because actually not 3 nodes now, because the low bond thing is a relatively new thing we added to the code recently, but typically it'd be 3 nodes, and it's typically those 3 attributes, because usually the version thing is not a problem. Everybody just upgrades, and nobody gets kicked out for that particular reason. You'll kick out those 3 nodes if the same guy was all 3 of those things for some weird reason or situation. I think it would still just get that 1 guy. I'm trying to think of the logic in my head, which I haven't looked at in a long time. Yeah, that's the downside of writing a large code base over the time span of 2 years. You get a little bit foggy sometimes on how the D8 works. You can look back at your own code and remember. But I think it just triggers. It just marks the node to be churned out. That node, if multiple do it, then I think we can just check real quick. Do mark old, for example. We do find old. Let's just see, how is he marked? Yeah, this sets leave score. Okay. Fine. Does it skip nodes that are already marked? No, it's not. Okay. So that you would mark the same guy out 3 times, and in the end, there just one guy get turned out, and then 2 people would be turned in, or actually 3 people would be turned in right now. This is where I guess the code gets really complicated about splitting, because I said before there can be multiple Asgards. So when you're churning, you're actually churning all the Asgards simultaneously. So if you have like 40 node operators and then you go into 42, you're now going to have one Asgard that you're going to split into 2. So you're going to have 2 Asgards, each with 21 nodes, effectively 21 validators in that particular Asgard. And so it splits them, and then it tries to figure out which node should be in which Asgard through just trying to get the bonds to be relatively as reasonably close to each other as possible. And then the funds get split between both of those things. And it can go the other way too. If you have 3 Asgards, you know, and all of a sudden there's less nodes in the system for whatever reason, it'll converge to 2 nodes, two Asgards. All that logic is pretty much here, which is somewhat difficult, complicated logic. I don't think there's any more of that. And block. What am I missing here? Get changed nodes. Processing Ragnarok. Ragnarok tools, Ragnarok the bonds. I'm not gonna get into that because that's kind of boring code. And will probably never be executed on this multi-chain, at least hopefully. That's all there is to that one. Yggdrasil is what it sounds like. This is how we send and fund Yggdrasil. Here's a fund function right here. This is how it defines this fund Yggdrasil funds. I have some sanity checks here to make sure we don't send it more funds than that bond actually, you know, designates. An interesting question I get sometimes of this scenario is that, like, well, what if Rune goes like drops 80% in value in Bitcoin and Ethereum and everything else stays up in value, and therefore the bonds securing that funds in Yggdrasil were not worth as much, and then it becomes economically incentivized for nodes to steal the Bitcoin and the Ethereum and the various assets. In reality, that actually would never really happen, because if Rune went down 80% all of a sudden for some weird reason, that would be an arbitrage opportunity for all the arbitrage bots, and so they would just start swapping Bitcoin, sending Rune into the system and pulling out Bitcoin and pulling out Ethereum and pulling out USDT. And so that would just start triggering the use of nodes to start dumping those assets to arbitrage bots continuously. So you wouldn't actually get that scenario. It would be nearly impossible. At least my understanding that's true. I'm not sure there's anything specific with this code to go through. I think validating that we send the correct amount of assets and we don't oversend it to assets is important. There are some sanity checks in here to make sure we don't do that. And we haven't had that scenario quite yet in production for single chain or multi-chain, but you can validate that code if you want to. This is where it calculates all the coins that it should have and what to send it. I believe, yeah. So this is what coins to send out. So when it abandons user vaults for the reason I was talking about earlier, and then there's a slash function as well to slash people when it makes sense to do so. But I'm not really sure where it does that in this code. Oh yeah, when they abandon their node, it would get slashed, obviously. So the manager.go is the manager's file that manages managers. Defines the interfaces here, defines the manager struct, which is passed everywhere in the code. And we're actually going to migrate to use this manager thing more heavily than we have in the past. There's some refactoring that needs to be done for that. But obviously a low priority right now, given all the things we're dealing with.
So Chad, yeah, just one question on the scenario you were describing about the big difference between Bitcoin and Rune values. How do you calculate the rune value? Where does it come from?
Well, we always know the value of every asset on the network, right? Because unlike Ethereum, THORChain is designed to be a DeFi protocol from the ground up, and it doesn't need any oracles. It has pools, right? It already knows of how much rune is equal to 1 Bitcoin because it knows the pool has X Bitcoin, X and Y number rune, right? So it always knows the price of every asset at all times. Like you can actually figure out the dollar value of anything, the rune value of anything within the THORChain network. You doesn't require a chain link to be an oracle of some kind of push in data. It just always knows from its pool depths what the price of anything is. And the pool depths are incorrect because, for a reason, that's an arbitrage opportunity, and some bot will come by and put in rune to get out Bitcoin, or put in Bitcoin to get out rune in either direction.
And what if you have the value of one of the assets being very different, like whatever, Ethereum dropping 80%?
If Ethereum drops 80%, like within the market price, or within the pool price?
No,
within
the pool price. So you would basically have different rune price. Right?
Yeah. So if that were to happen, naturally, what would happen is an arbitrage bot would push. If the Ethereum price is low, like let's say it's $300, but the actual price is like $2,000, whatever the current price of Ethereum is. That's an opportunity to like, hey, Ethereum is really cheap right now in the system. If I put in, $300 of rune, I'll get out $300 of Ethereum, which is actually going to be much higher in value. And so arbitrage bots will arbitrage that pool to put the Ethereum price back up to its market price, which would be around $2,000 or whatever the value would be.
Okay, thanks.
Yeah, it's the same mechanism as Bancor and Uniswap and everything else out there. It's when there's a price divergence, there's an opportunity for somebody to cash in. It's actually literally money on the table. Anybody can do it. Anybody wants to do it and make money, go right ahead. It's free money on the table, go ahead and take it. And that effectively happens every time there's a swap, right? Somebody swaps and changes the pool price. They put in rune, they take out Ethereum, the pool price is now incorrect. So then an arbitrage bot puts in Ethereum and takes out rune, right? And they make a profit in doing so. But the pool as a whole will generally make more of a profit in that scenario, because the swap over here, let's just say put $10 in fees that are collected and left in the pool, and then the swap on the other direction takes away from that, maybe like $1 or $2 or whatever it might be.
Yeah. And how hard would it be to fake one of the asset price?
How to fake the asset price? Like, what do you mean by that?
Like pretending that Ethereum price dropped to force some arbitrage out and essentially making the pool lose value.
Anybody could do that in theory, but you would do it at your own economic loss, right? Like if I wanted to fake the Ethereum price to be $300 for some reason, I don't know why I would do that, but let's say I did want to do that. I would put in Ethereum and take out rune in a swap, or I could do an add liquidity, like a single-sided add liquidity. Just add in rune on the rune side, which would cause the Ethereum price from the network's perspective to be down. But by doing so, you're going to be arbed out, and you're going to lose money by doing so. Like you're going to be down on your like from your initial investment. Or if you're going to do it from a swap, you're going to put in $100 of Ethereum, and you're going to get out $90 worth of rune, and you just did that at a loss. Now you've just manipulated the pool price somewhat, right, by doing so for that $10 loss. But because THORChain uses doesn't use XYK in the same way of 30 basis points of what you see on Uniswap, historically speaking, it has a slip-based model. So the larger the swap, the more fees you're paying. So this is actually something this attack that you're talking about, something we saw on Uniswap all the time. It's called a sandwich attack, where you just push the price back and forth like crazy, and you can actually create opportunities to make money that way. But you can't really sandwich attack on THORChain, because you have to make large trades to push the price. If you want to push the price of Ethereum from $2,000 to $300, that's of a pool that's like $15 million deep or $1 billion deep, whatever the depth of the pool is. It takes a lot of economic pressure to do so, especially because of the slip-based system, because you'd pay massive amounts in fees. You'd be gone hundreds of thousands of dollars, and so it'd be economically stupid to do that. but you could if you really wanted to. And if you did, somebody else would come back over and make a profit from doing it. So you'd lose, somebody else would win.
Okay, yeah, thanks.
So the manager here, this is the begin block. This is when I took before, like the network kind of like changes version. This is where that kind of happens. At the beginning of every block, it kind of analyzes the lowest active version. This is the question someone else asked before about, like, oh, how does it know what version it's on? Well, it looks at all the active validator state and finds the one with the lowest version that's currently being run. And if the version's been changed, you know, it'll get a new keeper, a new gas manager, a new event manager, a new vault manager, a new observer manager, a new queue, swap queue, et cetera, et cetera. You know, just that's how it changes all the code in a particular block simultaneously on all nodes across the system, which is pretty cool actually. Makes it really complicated from an engineering perspective, but it's really flexible and powerful. It allows us to make changes really fast and make solve problems a lot faster. Anyways, and here you can see like how often every manager gets updated, and you can actually tell how many times code gets touched through how often these versions can show up here. Okay, that is the manager. I'm not going to go into module or Mimir stuff too. This is actually the Mimir addresses that are valid. Query is just the API. The THORChain API. I don't think I need to dive into that. This is the router upgrade controller. So this is how the network updates the router, the Ethereum router, or eventually the Binance Smart Chain router, for ERC20s to hold and that kind of stuff. That can be done on churns, and we've done that once already in the network, which was a huge pain in the ass. It usually is a pain in the ass. And we even had more problems because it wouldn't upgrade because USDT is like a non-standard ERC20. It's a real pain in the ass to work with. It sucks. Whoever wrote that smart contract had, I don't know, maybe the standards weren't in yet or something. I don't know what it was, but it's just a piece of shit if you ask me. This is the swap logic. So this is probably a good place to look for attack vectors if you're going to look for attack vectors. This is where the logic of how swaps are actually executed in the network. You can dive through this on your own. It has code here for synthetic assets as well, which is currently feature flagged off. And even here, where did it go? There's a Mimir setting to enable and disable synthetics just for safety purposes. Eventually we'll kill that entirely, but being a new feature, we want as many safety guardrails on it as possible. So if anything goes wrong, we can disable shit and fix problems. So it has the ability to do a double swap. And double swap is basically, as it sounds, you're swapping twice. Because if you want to go to Bitcoin to Ethereum, you have to put in your Bitcoin, swapping it to Rune, and then Rune goes to another pool, goes from the Rune to Ethereum. So you're effectively doing two swaps there. But that all is handled within this logic here. It's kind of obfuscated from the user from their perspective that I put in Bitcoin, I got Ethereum. But in reality, what's happening is doing actually two trades on your behalf, which is actually interesting because if you do like $100 of Bitcoin to $100 of Rune, and then $100 of Rune to $100 of Ethereum, minus the fees of all that, the trade volume of Bitcoin went up to $100. The trade volume of Ethereum goes up $100. The trade volume of Rune goes up $200. It's actually an argument of why it's possible for Rune to become the most liquid asset in crypto in terms of trade volume, is if this network becomes the thing that I think it's going to become, the number one exchange in the world. It will cause Rune to be the most liquid asset, which is kind of a fascinating idea. Yes, so there's a swap one function here, which goes through all this logic. I'm not going to dive too deep into this stuff. You can explains all the X, Y, K, or the slip-based model here. You guys are welcome to dive into this code. It's pretty well seasoned. I'd be surprised if there's any exploits in here. It's been around for a while. We've vetted it many times, but you never know. You never know. And then the last thing in this directory is the withdrawals, which is exactly what it sounds like. Withdrawal logic. This is a little bit trickier. Also give you another attack vector. Oops. This is where like impermanent loss is actually calculated here as well, to figure out whether or not the person has impermanent loss and it should be paid back. It's a kind of a unique feature of THORChain is impermanent loss protection. to ensure people don't get too much permanent loss. All that's calculated in this little kind of code base here. And also you can do asymmetric withdrawals. So you can effectively, you own part of the pool, so when you withdraw, you're getting Rune and Bitcoin. But if you might tell the network, I don't want, Rune, I just want my Bitcoin. And so if mathematically what happens is you swap the Rune into Bitcoin and then you take out your Bitcoin minus the fees of that. But it's not an actual swap taking place like in the traditional sense. It just mathematically simulates that in a way. And you get minus your LP units and all that kind of stuff. I'm not going to dive too deep into this. I think this code is pretty self-explanatory. And this is where it calculates impermanent loss, blah, blah, blah. All that stuff can be analyzed. Okay. All right, so the last bit of this is the types directory, which I'm not actually going to go too much into. And there's a lot of things in here. There's 162 files, which is a lot of stuff. I'm not going to go through even 10 of these files because I don't think I need to. But this is where you define your structs for the entire system. Each one of these things, like if you notice they all have PB here. That's because in the new version of Cosmos, everybody uses protobuf instead of like its own serialization. We used something before called Amino, I think that's what it's called. It was using something called Amino they hand rolled their own way of like encryption, not encryption, but to store the data in a binary format. And so they recently in Stargate, version Stargate of Cosmos, they changed it to protobuf. So all the protobuf stuff you'll find in the protobuf directory. And so you could do like types pool, for example, where it defines the struct in a protobufy way. Protobuf's actually really cool. It's like saves like 50% of the block space. So it makes a lot more transactions per second that the network can do. The block can put more transactions in a particular block, which is really nice. And it's well documented. It's been around for quite a while. It's a pretty nice system, actually. Those are defined here, as well as the message types. So if I do like a message swap, for example, I can see the different types there, and that will effectively co-generates message swap.pb. And again, all this code is generated by protobuf itself. Nobody writes this code. So if you're auditing, you can just skip this file in a sense, because none of this is generated by the team. This is pretty ironclad code, I would say. I'd be surprised if it wasn't. But then you have the type pool here, where this is just defining the functions of this message type or type. Calculating units, blah, blah, blah. This stuff should be pretty self-explanatory. Like this is doing asset value in Rune, like convert this amount of asset value like Bitcoin into the Rune value. And this is doing the Rune value into the asset back and forth to get the price of the other thing or the quantity of the other side of the pool. But you can walk through these things yourself. They're plentiful in here. There's lots of them here for every message type. There's at least 2. And that's that in a nutshell. I don't think I need to go into individuals. Oh, one thing I should probably cover though is that each one of these things has a message, and the message has a validate basic function. This is the only thing you might want to validate or look for possible exploits. Is the validate basic message should validate that the message is valid, that it's not doing anything too crazy or too wacky or anything like this. It has to be low level checking. You can't like look up the KV store and see if this transaction ID actually exists, for example. But you're checking to see like, is this address valid? Is the asset, empty? Is there more coins than there should be? Is the amount in this thing 0? These kind of validations can be done here. Is the affiliate fee something? All this basis points something, whatever. You can validate all these things here and these functions. Okay, that's all I'm going to go for right now in this thing. Unless anybody has any questions that they want me to go over. I think the last thing, oh no, second to last thing, the memo directory has, I think I touched upon this earlier about how it parses memos. So this is where you're getting user input. So this is a good place to look for exploits, to see if there's any kind of like SQL injection like concept. I mean, there is no SQL here, so you can't do a SQL injection. You can't manipulate the number of coins you've sent in through a memo, right, or anything like this. But maybe there's some sort of thing you can do that somebody who's more clever than I can think of. This is a good place to kind of write some tests or to kind of probe for any kind of potential vulnerability of some kind. I think, yeah. And then now the last thing is the keeper. And there's only been one keeper so far. We don't change this code very much. It's pretty stable. That's largely because there's no logic in this code. It's just gets and sets, almost entirely gets and sets. There's very little actual logic in this code. Maybe one example where it's not, but it's very simple, which is why this code has almost never changed. This is how you interact with the keeper itself, the KV store that gets replicated across the network to add and set stuff. Any questions about this? No? Okay. I think that's the high level of my little talk. How long have I been talking here for? Almost 3 hours? 2 hours?
No, just under 2. This is a lot of, this is a lot of surface area, but also super useful for everybody who's getting right in.
Yeah, this is a lot of surface area. Thanks, Kai.
I mean, I've heard it about 50 times, but that's fine.
Yeah. That's my spiel from a high level. People, if anybody has any questions they want to probe me on, this is a great time to do so. To ask implementation questions or anything you want, go ahead.
What's the best way to funnel questions after this call chat?
Excellent question.
It's almost, one thought is maybe we should put together like a white hats channel in Discord. There's a few ideas there, but maybe that's a good starting point.
We could create a white hat channel. We could just use the THORnode channel possibly.
Yep. And we have the internal auditors channel, Chad, that you created. That we started in there too.
Yeah, I created a channel called Auditors Lounge for Trilobits and for Halburn. We can invite more people there.
Well, let's keep that channel for the formal audits that we've engaged.
That one only for security audits directly handling codes, so it doesn't turn into like an echo chamber of security.
Correct. And these white hat questions will be sort of a mix of like audit and general knowledge questions. And I think those general knowledge questions are definitely useful to be out in the open for the community, right? So if you're asking general questions about, how does this code work? What is this interface like? What's the relationship between this? That's a really good knowledge transfer to the rest of the community. So, I would choose the location of your questions more carefully. But if it's something that's sensitive, certainly like the white hat channel, which I think is a good idea, Gavin, that's a great place.
If it's sensitive, don't put it in the white hat channel because, well, assuming everybody in the white hat channel is a white hat.
Well, not sensitive in the sense that like it's like I think I found something, but like probing deep where there could be some insinuation, like that's a bit different. Anyway, does what I said make sense? If there's general knowledge, if it's just people learning about the protocol, then put it in the channel that it should be, like in THORnode. Like that's a great place for it.
THORnode works. I'm in there, and Heimdall is in there as well, and answers questions as well. The two of us are probably most familiar with the code base out there in the world. All right, we'll cut the channel for everybody. There's some questions in the chat, or I didn't miss something.
No, just comments in there. Okay. We've got everybody. I mean, it was almost 2 hours. Any last questions before we cut the recording and probably head our ways? All right.
Cool.
This is awesome. Thanks, Chad.
It's a lot, guys. If you're overwhelmed by it, you should be. It's don't feel discouraged because you feel like it's a lot, because it is a lot. So don't keep on it. Ask questions.